Okay, so let's look at a few questions from binomial distribution. Number 5. In a multiple choice test that contains 10 questions, with each question having 5 possible answers, what is the probability that Colin will pass the test if he merely guesses at each question? Diane will pass the test if she studied and feels that her probability of answering each question correctly is 0.75. Okay, so it's a little bit of a long, tedious question, but if we have a multiple choice with 10 questions, the number of trials is equal to 10. And since Colin is only guessing, and each one has 5 probable answers, the probability of success is 1 out of 5. So Q is the probability of failure, which is 4 over 5. And this is number 5. Okay? What is the probability that Colin will pass the test if he merely guesses at each question? Okay, in part A, we want to know the probability of a pass is equal to if he gets 5 questions right, or 6 questions right, or 7 questions right, or 8 questions right, or 9 questions right, or 10 questions right. Man, that seems like a lot of work. How many? 1, 2, 3, 4, 5, 6 calculations. We could go 1 minus the probability of 0 getting 0 questions right, minus the probability of 1, minus the probability of 2, minus the probability of 3, minus the probability of 4. I'm going to cough into this thing. Excuse me. So that's going to be 1, 2, 3, 4, 5. Well, I don't know. There's still a lot of calculations, no matter which way you look at it, right? So let's look at it. Out of 10 trials, I'm going to do this one. We have calculators. We want to get 5 correct. The probability of a correct answer is 1/5, and there's going to be 5 of those, right? And then 4/5, and that's going to be 5 wrong, right? 5 right, 5 wrong. Plus, we want 6 questions right. 1 over 5 to the 6, 4 over 5 to the 4, right? Because 6 are right and 4 are wrong. Plus 10 choose 7, 1 over 5 to the 7, 4 over 5 to the 3, plus 10 choose 8, 1 over 5 to the 8, 4 over 5 to the 2, plus 10 choose 9, 1 over 5 to the 9, 4 over 5, plus 10 choose 10, 1 over 5 to the 10, and 4 over 5 to the 0. Do I need to calculate that? It, pardon? Yeah. If you want me to calculate it, I will. Yes? It's up to you. Who asked the question? Would you like me? You got a different answer? Oh, so you actually went through this whole exercise and let's give it a try. What the heck, it won't hurt us. 10 NCR 5 times 0.2 the exponent 5 times 0.8 to the exponent 5 plus 10 NCR 6 times 0.2 the exponent 6 times 0.8 to the exponent 4 plus 10 NCR 7 times 0.2 the exponent 7 times 0.8 to the exponent 3 plus 10 NCR 8 times 0.2 the exponent 8 times 0.8 to the exponent 2 plus 10 NCR 9 times 0.2 the exponent 9 times 0.2 to the exponent 1. Oh. Do I plus delete or AC? One of these will. Oh, dang! Oh, dang. I deleted everything. I should have pressed delete. Okay, I'm going to do it. I don't care. 10 NCR 5 times 0.2 the exponent 5 times 0.8 to the exponent 5 plus 10 NCR 6 times 0.2 the exponent 6 times 0.8 to the exponent 4 plus 10 NCR 5 times 0.2 the exponent 7 times point. Oh, 10 NCR 7. Yeah. 0.8 to the 4, 10 NCR 7 times 0.2 to the exponent 7. Did I do that right now? Times 0.8 to the exponent 3 plus 10 NCR 8 times 0.2 to the exponent 8 times 0.8 to the exponent 2 plus 10 NCR 9 times 0.2 to the exponent 9 times 0.8 plus 10 NCR 10 is 1, 0.2 the exponent 10, and that's 1. I got 0.0328. Is that what you got? So is the answer wrong? Huh? Oh, okay. So that was 0.033. Okay, fair enough. Now, the only difference with the next question, and I won't do that one, is now your probability of success is 0.75 and your probability of failure is 0.25. So instead of putting 1 over 5, you use 0.75, but it's the same thing. Number 6, assuming that the chance, so before I go on, do you see why this is a binomial distribution? Two outcomes, you either get the question right or you don't. The probability of getting it right never changes. The probability of failure never changes. Okay? Right? Let's look at number 6. A couple is planning to have 3 children. So n is equal to 3. And we want to know that the probability of all 3, we get 3 girls. So let's let G be the number of girls, right? The number of outcomes is 3 because there's 3 children. And the probability of getting a girl is a half. The probability of failure is of having a boy is a half. So let's just see how we can do that. So we want 3, choose 3. So probability G equals 3 is equal to 3 choose 3, 1 half to the 3 times 1 half to the 0. Is that just 1 over 8? Yeah? Good. Is that the answer at the back? Yeah. This was number 6a, right? So 1 divided by 8 is 0.125. Okay. Part B. A couple planning to have 5 children will have at least 1 girl. So we want the probability G is greater than or equal to 1. So that's going to be probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. So that's too much work. We'll just go 1 minus probability of 0. That is equal to 1 minus. Now the number of trials is n equals 5, right? 5 choose 0. Probability of a girl is 0. Probability of a boy, and that's to 5. So that equals 1 minus 5 choose 0 is 1, that's 1. 1 over 32. And that is 31 over 32, which is approximately 0.9, 0.96875. Yeah, 0.969. Is that okay? Are we good for number 6? Okay, let's look at number 7. Assume that every time Murray a hockey... Oh, you didn't ask for number 7. Somebody asked for number 11. If the probability is 0.15 that Luciana will hit a bullseye on the dartboard, what is the probability that she will get at least one bullseye in 10 attempts? So n equals 10, and we want the probability that a bullseye is greater than or equal to 1, and the probability of a bullseye is equal to 0.15. Probability of failure is 0.85. Okay, so probability B is greater than or equal to 1 equals probability of 1 plus probability of 2 all the way up to probability of 10. So that obviously is too much work, but we can go 1 minus probability of 0 bullseyes. So that's going to equal 1 minus 10 choose 0. Probability of a bullseye is 0.15 to the exponent 0, 0.85 to the exponent 10. So that will equal approximately 1 minus 0.85 to the exponent 10, 0.8031. Number 11. Okay? And number 13, find the probability that at least 3 students, here I'll just show you that here. Find the probability that at least 3 students in a class of 30 were born on a Saturday. Okay, so there's 7 days in a week. Here's 13. N is equal to 30. Probability of success, well, the probability of being born on a Saturday, that's 1 day out of 7. Probability of failure is 6 out of 7. Find the probability that at least 3 students were born on a Saturday. Okay, so we'll just say probability S is greater than or equal to 3 equals, well, probability of 3 plus probability of 4 all the way up to probability of 30. So that's too much work, so we'll go 1 minus probability of 0 minus probability of 1 minus probability of 2. So it's 1 minus 30, choose 0, 1 over 7 to the 0, 6 over 7 to the 30. Boy. Minus 30, choose 1. 1 over 7 to the 1. 6 over 7 to the 29. Minus 30, choose 2. 1 over 7 to the 2. 6 over 7 to 28. And that works out to be 1 minus open bracket 6 divided by 7 close bracket exponent 30, because I know that's 30 choose 0 is 1. That's 1, so I just have to enter that into my calculator. 30 choose 1 is 30 times open bracket 1 divided by 7 close bracket times open bracket 6 divided by 7 close bracket to the exponent 29 minus 30 NCR 2 times open bracket 1 divided by 7 close bracket to the exponent 2 times open bracket 6 divided by 7 close bracket to the exponent 28, and I got 0.8226, which is okay. Can I explain anything better? No? Okay, so remember, like in this born on a Saturday, you have two outcomes, right? You're either born on Saturday or not born on Saturday. Okay, so there's two outcomes. That's a characteristic of binomial. Probability of success is 1 over 7. When I'm born doesn't affect when you're born, right? And that stays the same. Trials are independent. So that's why it's binomial. And it's repeated trials. It's just kids being born, right? The births keep on happening and happening and happening. Repeated trials. Can I explain? Was there anything else in the homework you'd like me to go over?